I think we have an interesting topic today, talking about how Azure SQL Data Warehouse performs against its competition. So this should be a fun, interesting topic. Quick agenda. We'll start quickly with an overview of what Azure SQL Data Warehouse is. If you're kind of new to the product, I'll give a brief description of the product itself. And we'll talk about some of the other competitors in the cloud scale analytics market. And a lot of what we're going to talk about today is focused on a benchmark study that Microsoft worked on with a company called GigaOM, and where they did some performance and cost comparison of all of the, or a few of the products in the market here. And then we'll spend a little time talking about what's new with Azure SQL Data Warehouse and why it's becoming more and more compelling to adopt it. I've got a short demo at the end as well, and let's get into it. My name is Bob Rubocki. I'm a practice manager and BI architect with Pragmatic Works, and you can reach me at email, or Twitter is probably another good one. And we may have a blog post up after this presentation, and we'll find that at pragmaticworks.com or also on my blog site there as well. So if you have any questions about today's session, please feel free to reach out. So I want to talk about Azure SQL Data Warehouse, the product, and what it is, and then we'll talk about how it fits into the marketplace with its competitors. So when we're talking about Azure SQL Data Warehouse, we have to talk quickly about this concept of massive parallel processing, or MPP. And so the diagram I have here is from Microsoft, and it's a kind of a high-level architecture diagram of the way that Azure SQL Data Warehouse works. So some of the highlights here are the separation of what we call the compute nodes from the storage. So the data storage is separate from the compute nodes, and that's a really key part of the architecture. Now, the way that you connect to Azure SQL Data Warehouse is connecting to the control node that you see in the diagram. And so this looks and feels in most ways just like connecting to a regular SQL server. And then when we run queries, those queries are issued to the control node, and the control node will then distribute that query to each of the compute nodes. And that's how we get that parallel processing. So in this example here, I've got the 4 compute nodes, so one query would be, that workload would be spread across those compute nodes, each of which would return a partial data set to the control node, which would then render your final output. Now, one of the really nice things about this separation of compute and storage is that we can scale the compute up and down as needed very easily. So that's good for cost management. And also, as your needs change, you can just adjust the compute power of your implementation pretty quickly without having to do anything with the underlying storage. So changing the compute power is really common, for example, during times of day where maybe you've got really high workload demand. Maybe you want to scale up your architecture, and then maybe in off hours it's not as heavily used, and you can scale that down, and you can really do that to manage cost. The other thing we can do with the compute nodes is we can actually pause them entirely, which is essentially turning off the compute. So you're not paying then for the compute when it's turned off. You do have to pay for the storage of the data underneath it. That doesn't go away, but this platform allows for that level of flexibility for scaling up, scaling down, and managing your cost. So why would I use Azure SQL Data Warehouse compared to another, just like Azure SQL Database, for example? SQL Data Warehouse really is designed to operate on massive data sets, and it's really designed for your analytic and aggregation type queries. So it's not an OLTP system. It's not good at looking for a needle in a haystack, so to speak. And so it's really designed for doing analytics on massive scale data. Now, as we're going to talk about a lot today, Azure SQL Data Warehouse is not the only one trying to solve this use case. There are other products in the market that are doing similar kind of work. And when we talk about this market, we are talking products that include some of the features that I've listed here on the screen. So obviously, it's cloud-based. That would be the first condition. The second one is really important here too, is that we're dealing with a relational database. In parentheses, I just put SQL, and what I mean there is that the competing products all are implemented a little bit differently, but they can each be queried with SQL or a variation of SQL. And so that's a key part of the a key feature of the products in this space, is that they're queryable with a SQL or SQL-like language. All of the products in this market space can deal with both structured and semi-structured data. So when you're talking about querying data, maybe from files, maybe it's stored in JSON, et cetera, these products generally will be able to do that. And they're all going to be built on some type of scale-out architecture, like I showed there with the MPP, with the Azure SQL Data Warehouse. And the other products in this space then too are characterized by using columnar compression. And so this in Azure SQL Data Warehouse is your column store indexes, and this is a really powerful tool for powering analytics and aggregation over large quantities of data. So for today's discussion, we're going to focus on these products here. So I mentioned Azure SQL Data Warehouse from Microsoft, and we're going to talk about how that product compares with Amazon Redshift, Google BigQuery, and Snowflake. So if you go out to Microsoft's Azure SQL DW page right now, you'll see something that looks very similar to this, where they're making reference to some stats and an analyst report that was done by a company called GigaOM. And so what they had done was commissioned a study to compare Azure SQL Data Warehouse to Google, Amazon, and Snowflake on the basis of query performance, but also the cost of running those queries. And so we're going to talk a lot today about the results of that study and Azure SQL Data Warehouse's position in the market as far as performance and cost. Now, a little bit about the study or the research. It's based on a benchmark called the Tps Th Benchmark, and this is a decision support benchmark. You might be familiar with TPC. They are the ones that really have the benchmarks for transactional processing. And quick note there that TPC, I got this from their website, which I've referenced there at the bottom. It's short for the Transactional Processing Performance Council. And this is the group that over time has established these benchmarks. And so they really got started trying to create standard testing methodologies and data sets and queries for online transactional processing. And that really kind of grew out of testing ATMs, which I thought was interesting. So that's a little bit about the background and the benchmark that was being used for this study. So TPC really is made up of, it's a group that you can join, and these are the companies that pretty recently made up TPC. And so over time, this group has changed. People have kind of come and gone, but these are the companies that have input as far as how that benchmark should be maintained. So regarding the methodology of the study, again, it was based on this TPC-H benchmark, which is this decision support benchmark. And that benchmark includes very specific details about the schema design. So it outlines the tables, the fields, the data types to use when you're doing your benchmarking. And that schema is available on their website, and you can see everything that's in there. They've also outlined the queries to execute. So they've come up with, looking at my next bullet there, 22 queries in this benchmark that perform different types of analytic workloads. So a lot of summings and min and max, and looking for existence of an item in a table. But there are 22 queries that they've identified and written to be used. Now those queries, they do need to be adjusted per the individual platform, and I'll talk about that in a little bit, but they do outline specifically the 22 queries and the use cases. So GigaOM for this test populated this benchmark schema with a data set that totaled 30 terabytes. And each of those 22 queries was executed 3 times. And so for the purpose of comparison across products, they kind of gave everybody the benefit of the doubt and said, okay, for each of those 3 executions, we'll take the best time. And so those are the times. I'm going to show you some of the results of the research. And so just keep in mind that the results that we're seeing are really the best of 3 executions. Now, when testing the products, so I mentioned Azure SQL Data Warehouse can scale up and scale down. Amazon Redshift and Snowflake offer similar capabilities where you can kind of scale and design your architecture as needed based on your workload. So for this study, there were 3 separate Azure SQL Data Warehouse configurations as well as 3 Amazon Redshift and Snowflake configurations. As it is, Google BigQuery does not have that configuration that the other 3 products have. So there was only 1 instance of Google BigQuery used for this study. So this is a little bit of the background about how the study was conducted. And here's an example of the results of the first query. So remember I said there were 22 queries that were part of this. On the left side, I'm showing a sample of the SQL. I pulled this from their website. So this might have to be adjusted depending upon the platform that's running. But that's just to give you an idea of the type of query that it's running. And on the right side, we see the results of that, the query execution, just the straight performance. And so what I've highlighted here, we'll talk about this more in a second, for the purpose of comparing products, you know, each of the platforms, well, the Microsoft Redshift and Snowflake were run on 3 different scales, and Google BigQuery was executed once. So in this particular example, on this query 1 called the pricing summary report query, the lowest level SQL Data Warehouse that was tested returned a result in 78 seconds compared to 104, 158, and 124 seconds for the other competitors. And then likewise for this middle tier that was tested, it was 26 seconds compared to 35, 74, and 124, and so on. So I've got a few of these examples. I just want to outline how the comparison was done. But this is an example here where the Microsoft product, and this is just the first query of 22, really outperformed Redshift, Snowflake, and Amazon BigQuery. I'm sorry, Google BigQuery. So again, 22 queries run on 3 different instances of Azure SQL Data Warehouse was a total of then 66 executions. And so when we line those 66 executions up against the 3 competitors, just on which one was faster, when we compare to Amazon Redshift, 54 of those 66 queries, and I think my math is actually a little bit off there, but 54 of the 66 were faster. And let me close this here. Looking at Snowflake, 62 out of 66 queries were faster on SQL DW than they were on Snowflake. And when talking about Google BigQuery, of the 66, there was only 1 instance where Google BigQuery ran faster than Azure SQL Data Warehouse. So you can see just in summary that Azure SQL Data Warehouse does very well compared to Redshift, Snowflake, and Google BigQuery. There we go. So I want to look at a couple other examples of some of the other queries, and actually I'll highlight some of the cases where Azure SQL DW did not perform well, but we can kind of see based on the results kind of, you know, how close it was. So this is one case where Amazon Redshift performed a little bit better than Azure SQL DW. So in this case here, the larger implementation of Redshift executed this query 3 in 16 seconds, whereas it took 20 seconds on a comparable Azure SQL DW instance. But you will notice that on the other instances of SQL DW that it does perform better at that end against Redshift, Snowflake, and BigQuery. So this is just an example of where Redshift did outperform Azure SQL DW in this particular instance. And then likewise, where generally speaking, Azure SQL Data Warehouse performed very well against Snowflake. This is an example where Snowflake did outperform Azure SQL Data Warehouse, so you can see the stats there. So on the higher end, Snowflake was, a second faster on this particular query. This is the 22nd query in the set, and one of the highlights here you can kind of see on the left side. This query was really long, so I had to cut it off just so we could read it. But this one included a lot of subqueries, and in this particular case, Snowflake seemed to do a little bit better there. But again, Microsoft SQL Data Warehouse still competes very well here, and so. But I did want to show an example where Redshift did in this particular case outperform. So I mentioned there was one case where Google BigQuery did outperform Azure SQL Data Warehouse, and it was in this case here, was in query 13, which is called the customer distribution. And I've got a sample of what that looks like there on the left. But you can see here that the BigQuery result came back in 213 seconds. And on the low end, the lowest end that was used in the test for Microsoft came back in 222 seconds. So still in the ballpark, but you can see that as you move up on the power of Azure SQL Data Warehouse, that it does outperform Google BigQuery. So I just wanted to show that as an interesting data point of what was that one case where Google did outperform Azure SQL Data Warehouse. Now, as far as price, so the GigaOM study included the cost that was incurred to run the query. So the way that they did this was they just took the total duration of those 22 queries that was run on each of the platforms and added that up, and then just said, okay, for the time it took to run those 22 queries kind of end to end consecutively, what does it cost to operate the service during that duration, okay? And so taking that cost of duration for the amount of data that was processed here, we come up with the numbers that we see here. So this is just a relative scale showing that on the whole, for the platforms that were tested, Azure SQL Data Warehouse was less expensive than Snowflake, Google BigQuery, or Redshift. Now, it's something that's important to know here on the price per performance metric is that Google does not charge or operate on a per hour basis the way that the other platforms do. So that cost number was really based on, so Google charges on the volume of data that was processed. And so whatever the cost associated with running those queries on Google, that's the number that was used to compute the price per performance metric here. So looking at some of these in a little bit more detail, looking at SQL Data Warehouse against Redshift, we can see on the three comparable platforms that were tested that, at the high end, they were pretty similar in price there with SQL Data Warehouse, only not quite 8% cheaper, but more significantly cheaper, kind of at that lower end of the spectrum. And I say low end, the platforms that were tested were actually pretty powerful platforms. There's a wide range, and they just kind of picked those three. But we can see here that Azure SQL Data Warehouse, generally according to this research, is less expensive to operate than Amazon Redshift. Now against Snowflake, again, this is just in terms of the workload that was tested, it's going to be quite significantly less expensive to run that workload on Azure SQL Data Warehouse than it will on Snowflake. And so where we were talking 25–30% on Amazon, we're talking a couple times cheaper here. And so we can see in the middle there that middle tier, SQL Data Warehouse is actually over 3 times cheaper than running on Snowflake. So that's a pretty significant difference there. Now comparing against Google's BigQuery, the image on the left I actually pulled from Microsoft's website, and so this number comes from is from this study here. So we can see that Azure SQL Data Warehouse on the whole really is quite a lot less expensive than Google BigQuery as well. So I want to move on and talk a little bit about what's new in Azure SQL Data Warehouse. What are some things that really helped in those performance benchmarks, and what is Microsoft doing to develop Azure SQL Data Warehouse and make it as competitive as it is? So most of what's new in Azure SQL Data Warehouse can be tracked back to headlines here is that Azure SQL Data Warehouse Gen 2 is running on all new hardware. It's more powerful hardware, and I'll show you in a second the architecture of that hardware and some of the components are different than the Gen 1. So that was a big upgrade there. The other big thing that was a big highlight of Gen 2 was addressing is it's designed to give you faster query But it's also in some of the software that's determining what data in our data warehouse is most frequently through a diagram. So looking at the compute nodes there, part of the highlight here is that they include now these
Hey guys, can you hear me? I just want to check in and make sure you guys can hear me really quickly. See Bob, if you can hear me, your audio is kind of going in and out. All right, guys, just hang tight. We're going to try to get Bob back on here. I think I see him in here, but I think his sound is just connected in and out.
if you're talking.
I can hear you, Bob. Can you hear me?
Okay, I can. Yeah. Okay, I'm gonna continue then.
Okay, go ahead.
Yeah. All right. So the idea with adaptive caching is that we can actually take data that was stored in column store compression that was previously stored on the remote storage, and Azure SQL Data Warehouse has an algorithm now that will identify those column store sets that are likely to be used or have been used recently in queries and actually pull them into cache in the compute node. So the benefit there is that in a lot of cases, but I can run a query that does not require Azure SQL Data Warehouse to read from the remote storage because I've had that data cached right on the compute node itself, and that's how that works and how we get that performance gain with the Gen 2 of Azure SQL Data Warehouse. So again, the whole idea is to take some of the data operations that used to be done on the remote storage and bring some of that data to the compute node and reducing or eliminating, in a lot of cases, the I/O that's required to read from remote storage, ultimately just giving us faster query performance. So that's a key change that's been made to the product over the last couple of years or so to really improve query performance in Azure SQL Data Warehouse. Another big improvement that was made was the limit or the high end of the number of concurrent queries that can be executed. So Gen 1 of Azure SQL Data Warehouse had a maximum of 32, and that was on the highest level installation or configuration, I should say. But with the release of Gen 2, that's increased to 128. So depending upon the scale that you're using, you have up to 128 concurrent queries. And that limit now does apply to the Gen 1 product as well since the release of Gen 2. So that was a big improvement in the product as well. And then Microsoft has just added additional performance tiers. So in Gen 1, we had a top end of 6,000 DWUs, and a DWU is really just the measure of relative power of the platform. And with Gen 2, we have 5 times that available. So we have SKUs that will take you up to 30,000 DWUs. And so they've just made available more compute power with Gen 2. And so that was a big improvement. And then more recently, they've actually added some lower price tiers for Gen 2. So when Gen 2 was originally released, you kind of had to start at a mid-level price and performance range to use Gen 2. But then more recently, Gen 2 now is available at those lower price tiers. So it's really available to everybody to use so that's a really great thing. So that's something that's been changed to the platform. So I want to run through a quick demo just to show a little bit about how we can get started here, and then we'll move into some questions. So the first thing I wanted to do, and I was worried this was going to happen, I got to sign into Azure. I'm just going to show how we can create a Gen 2 data warehouse. Whoops. This shouldn't take very long. Good. So to do this, I do need a logical SQL Server setup. So this is something that you need to set up in Azure. It's free to do that, but it's just a logical container for our databases and data warehouses. And so if I come out to the portal, I have this option here to create a new data warehouse. And really what I want to show here is just the options that we have at the performance level. So by default, you can see it's already pointing me to Gen 2. And here is where I have the choice of choosing a Gen 2 performance tier or a Gen 1. So I can still use Gen 1. I think more and more you look at the pricing, they're more and more similar, especially down at the lower end. So I think more and more you'll want to use Gen 2, but I just want to point out that we have that option today, and this is how you can make that decision of, am I running a Gen 2 or am I running a Gen 1 data warehouse, okay? Now, I have a couple queries that I wanted to show. So when we talk about performance and adaptive caching, we're really talking about being able to use clustered column store compression. And there's a number of the data management views in Azure SQL Data Warehouse. We can query them to actually understand how efficient or how well managed my clustered column store compression is. And the reason I want to monitor that is because it will definitely have an impact on performance. And so I just wanted to show, I have this view is available from Microsoft that's called row group physical stats, and it's going to tell me about the structure of my my databases, or of my column store indexes. And if I do, yeah, so I ran this ahead of time. I'm going to show you how we can do this in a second too, but in this data warehouse, I've actually loaded the famous New York City taxi data set. And I want to show you in a second how we can do that. That's available online, and it's really pretty simple to load into Azure SQL Data Warehouse. But I have a table in here called trip, and this is the table that has the largest number of rows in my example. I've got about 170 million rows in that table. And when I created that table, I used the clustered column store for the storage. And we have this, using this view and some of the data management views, I can look at the state of my column store compression to understand whether I'm using the most efficient storage or not. And looking at this table here, what I'm looking at, what I see here is this state of the column store compression. And when I see things like this, where something is open, it means that there's data being held in what's called the delta store, which means that there's some data that has not yet been able to be put into that column store compression. Now, there are a number of reasons why that happens, and it's not necessarily a bad thing, but I want to point out that the Azure SQL Data Warehouse has tooling and queries available to help us make sure that we're getting the most out of our column store compression, which will then ultimately yield better query performance, in part then because of that adaptive caching and the way that it can read the column store compression data from cache rather than from the remote storage. And so I just wanted to show that we have some tools available there. Now, I'll send a link. I've got it in the slides for how to load this New York City taxi data, but this was really neat. So Microsoft has this available on their site, where this data set is actually available out here in blob storage, and they've got all the queries and everything for using Polybase to read that data from blob storage into your data warehouse. And so I've done that, and I've imported this data into Azure SQL Data Warehouse, and just wanted to run a couple of quick queries just to kind of give you a feel for the speed. So this is just a query that runs against that trip table, which, if I recall right, has 170 million records in it. So it's, you know, modest size. The data warehouse that I set up is at a DW 100C. So this is at the lowest possible level, and quite frankly, the least expensive, and which is why I used it here. So on that lowest level tier, if I run as, and I got disconnected here. Let me just copy over my queries here. There we go. So I'm just going to run this quick query here that just does a sum. It just gives me a count of the number of rows in that table. And this is that New York City taxi data. So I just want to do a sum of all of the fares and the tips that were paid. And so we can see down here that this took 7 seconds to run. So return a result on 170 million rows in 7 seconds, and showing me the count and the total fare and the tip amount. And I'll just run one more query here just to give you an idea of the speed again. So this one's just a slightly more complicated with a join and doing a group by. So I just want to see the number of, from my data set, how many taxi trips that I have by year, and then for the day of the week. So I can just run this. And these generally should take not a whole lot of time at all. And so again, this is going off of the data set of 170 million taxi rides. And we can see that within 6 seconds, I can see that for the year 2013, that Fridays and Saturdays, probably not surprisingly, were my busiest for taxi rides. So I'm going to flip back to my slides here and talk a little bit about, kind of in summary, about the Azure SQL Data Warehouse platform. So we showed through the results of the study that was conducted by GigaOM that it really is a very powerful platform, and it stacks up really well against the technology. This slide here is showing us some reasons why it has tremendous business value, starting with developer productivity. If you're using SQL Server today, using Azure SQL Data Warehouse is very, very, very similar. So you don't need to learn a ton of new skills. There are some differences, but if you're using SQL Server today, you know, moving to Azure SQL Data Warehouse should be pretty smooth. The platform is really secure. You know, the data being stored in blob storage, etc. We've also got some security mechanisms built into the platform, such as transparent data encryption. That's all part of the platform. The intelligent workload management is kind of what we talked about with the adaptive caching, where it's going to understand patterns about how you're querying your data and which pieces of data are used more frequently and less frequently, and bring into that cache the data that's most likely to be used in queries. And that's really going to just give a good experience for people consuming data out of the Azure SQL Data Warehouse platform. Regarding data flexibility, so this mentions querying directly over data lake, which is really powerful. So if you do have files in data lake, or as I did in showed in the demonstration, reading data from blob storage, this platform can query that data as if it were in Azure SQL Data Warehouse, and then you can bring that data in and do your analysis there on the platform. But a lot of flexibility as far as you know, where your data is stored and how it's stored, etc., and still be able to bring it into Azure SQL Data Warehouse and do your analysis on it. And then, as we talked about with the GigaOM study, it just price-wise, it's definitely, compared to Google and Snowflake, it's considerably less expensive to operate, and of course very competitive. Cheaper, but not quite as cheap compared to Amazon, but it is very competitive price-wise. And so these are some compelling reasons to consider using Azure SQL Data Warehouse. So if this was a lot of information, Pragmatic Works can help. So we do a lot of work with this platform and with the Azure Data Platform. And so if you're interested in learning more about how we can work with your organization to help understand how to use Azure SQL Data Warehouse in your environment, we would love to talk with you. And so a good way to get that started would be to respond accordingly in the last survey question as you exit. And we'd love to talk with you about using Azure SQL Data Warehouse. I've got a few links to some of the materials I referenced here. So the GigaOM report is available online. And again, you can get to this from Microsoft's Azure SQL Data Warehouse product page. That TPCH benchmark spec is where it outlines the definition of the schema and the 22 queries that are used, et cetera. So there's a lot of interesting information there. And then I've included that link there to the New York City taxi data. If you want to get started with Azure SQL Data Warehouse, but you don't want to migrate anything, follow that link. It's a really great resource to import a pretty decent sized data set and start playing around and get familiar with the platform. So I encourage you to take a look at that if you're interested. And with that, Crystal, I'm available to take a few questions.
All right, awesome. You got quite a bit of questions in here. So let me scroll through here. All right, let me filter through some of these. Forgive me for saying your name wrong, Pratik. There is a recording that will be available. You will receive a link to the recording tomorrow, but there is a recording that will be available for this. There is a question from Alexander that says, most of the queries don't have joins, but in most data warehouses implementation, you have fact and dimension tables. So you will have joins. Do you know how to do these platforms perform with joins? Do you know how these platforms perform with joins?
Yes. So I think that one of the queries uses join syntax, and I just showed an example here that the way that the spec is written, it doesn't use the join syntax, but this is an example here where this particular query is pulling from a customer table, which is a dimension, and then orders and line item. And instead of using the join syntax, it's just making that connection in the where clause. So these queries did use or query data from multiple tables. It just did not use the T-SQL join syntax. So, but they absolutely can, and they did use joins here as well. So yeah, the whole idea with the TPCH benchmark is that the queries are, as the question suggests, data warehouse type analytic queries, right? So dimensions, facts, summarization, and that pattern. And so yes, that was implemented here. Good question though.
Okay, next question is from Alexander again. It says, is there a too small for Azure DW?
I wouldn't say there's too small. What I would kind of say the other way, that you want to be of certain size to get the benefit of it. And so the number that I use would be if your fact tables have, I always say 60 million rows would be the starting point where you're really going to start to see big improvement if you move to Azure SQL Data Warehouse. And the reason that is it just has to do with that's where you can start to take full advantage of the column store compression. And so anything less than 60 million records, it'll work well. It just can't take full advantage of the promise of the platform. So that's my guideline. There's nothing too small, but you're just not going to get any big advantage out of it until you get to that 60 million record threshold.
All right, the next question is from Nora. Can we use merge statements and CTEs in Azure Data Warehouse?
CTEs you can definitely do. The merge I would have to double check on. And I guess when I say that, and this is a topic maybe for another webinar, which would be interesting. Generally speaking, update statements do not perform well in Azure SQL Data Warehouse. And so generally what we do if we're loading or if we want to do that merge operation is we would change that to a series of inserts or select into to render a similar output as a merge. So that would be my answer there. The merge, I believe it is supported. I mean, obviously the update is supported, but again, we try to write patterns where we don't have to do that, just for straight performance reasons and nothing else.
Okay, the next question is, how different is Azure SQL Database compared to Azure SQL Data Warehouse?
So there are some differences. I mean, I think generally speaking, your select queries are the same. There's really no difference. The biggest differences are going to be in the way that you design tables. So for example, when you create a table in Azure SQL Data Warehouse, you have to specify what type of storage you want to use. Do I want to use a heap? Do I want to use column store compression? And those options are just not concepts in SQL Server. Those are unique to Azure SQL Data Warehouse. So it's more on the way you create tables and manage the data that's different. There are also some other subtleties, like there are actually no foreign keys in Azure SQL Data Warehouse, which is again another topic for another webinar. And so there are just some different patterns in the way that you handle your data in Azure SQL Data Warehouse that would be different from what you would do in traditional SQL Server. But the syntax, there are a couple subtle differences, but by and large is the same.
All right, the next question up here is, what ETL tools are available to build the data warehouse in Azure?
That's a great question. A couple that come to mind would be Azure Data Factory is really popular and common right now, and that's a good tool. Using Azure Data Factory instead of, so I mean, you can still use SSIS. Let me just say that. We can still use SSIS. Again, kind of to the previous question about the merge, the way that some of your slowly changing dimension logic works traditionally with the tool like SSIS and doing updates generally does not work well. So most of what we've done with SQL Data Warehouse comes to embedding that logic in stored procedures. And then you can invoke those stored procedures through SSIS or Data Factory, etc. Also, Databricks is becoming more common too, so maybe doing some of your dimensional logic in a tool like Databricks and then outputting a set that can be imported into SQL Data Warehouse is another way to do that as well.
All right, let's see. The next question we have up here is, what should maximize the size of your Azure Data Warehouse database?
Sorry, can you say it again?
What should maximize the size of Azure database? So
the maximum size, I think it's in my notes, but maybe I didn't say this. There is no maximum size of an Azure SQL Data Warehouse. The reason is because your data is stored in blob storage and you have virtually unlimited capacity on blob storage. So there is no maximum size for an Azure SQL Data Warehouse. And that's really a key difference getting to the cloud versus something on premises where you are bound by disk space at some point, and we just don't have that limit in the cloud.
All right, perfect. The next question is partition will be used here to improve performance?
Yes, partitioning in Azure SQL Data Warehouse is awesome. Definitely a thing, a very common approach for managing storage and query performance. So the answer is yes, yes, yes. I just didn't happen to demonstrate that today. So partitioning is great for query performance. It's also phenomenal for loading. So a pretty common pattern for instead of doing an insert into a table would be to do partition switching. And the syntax and the mechanics around it, in my opinion, are much simpler to implement on SQL DW than they are in on-premises SQL Server. That's a little bit of my opinion, but it's pretty simple and it's very powerful. So the answer is yes, yes, yes.
All right, perfect. The next question is, any big differences between Azure SQL Data Warehouse and on-premise APS Pdw?
There are. So some of that depends on the version of APS that you're using. I mean, certainly one of the big differences would be the capacity, right? So on APS, you're bound by server resources. One of the nice things about moving to the cloud is the ability to kind of scale up and scale down. Whereas if you are on APS, you've bought an APS and it is what it is. So you can't scale it up or down. As far as syntax and things like that, they're generally very similar. I say generally. There are things in Azure SQL Data Warehouse feature and syntax-wise that would be deployed to the cloud that are not deployed on APS. So one specific example I can think of, and I haven't tested this recently, is the ability to create a primary key in Azure SQL Data Warehouse. And I don't recall at the moment. I know on the older versions of APS and in SQL DW for that matter, you could not create primary keys. But now in SQL Data Warehouse, you can, and they're used logically for the query optimizer to figure out a good query plan. But I believe that's one example of something that's different, kind of syntax and structure that's not available in APS. And again, the cloud and the separation of storage and compute, and then using the blob storage underneath is different. And then of course with Gen 2, a big difference then, and this is not as big a concern with APS because you're running on the same machine, but this whole idea of the adaptive caching is something that's only available in the cloud product then.
All right, perfect. I think this is the last question up here. Let me make sure. Oh wait, there's a couple more that got added in here. Okay, can we join tables from 2 different DBs in Azure SQL DW?
So databases, you have to set up an external data source, and it's using Polybase would be the way to do that. I have not done that against a database, but what I did when I imported that data from blob storage, it's a similar idea where you make a reference to an external data source and then you can query it. I know you can do it on Azure SQL Database where you can set up elastic query operations between 2 databases. I'd have to get back to see definitively whether or not you can do that in SQL Data Warehouse. I'm not sure at the moment.
All right, next question is it compatible with Informatica and other ETL tools?
Yeah, Informatica, I believe that it is. I mean, it's just you're making a connection to a SQL database. So I mean, I haven't used that specifically, but you should be able to connect to it just like any other database, just like SQL Server.
Okay, second to last question here is from Chase. Current AU of APS doesn't have that. Does it? I don't know if he means does it have that or doesn't have that.
Okay. So what's the question? I'm sorry.
It just says current AU of APS doesn't have that. So I'm thinking he's just.
Okay. Yeah. Sorry. I would need a little bit more context to answer that, I think.
It says also having a feature of elastic pool. It also having a feature of elastic pool, primary keys, that is.
Okay. Yeah, the elastic pool is a concept that applies to SQL database, and so that's not something that applies to the SQL Data Warehouse. That's a little bit different topic. So the idea of a data pool, or the database pool, is that you can share resources across multiple databases, and that's And I'm 95% sure that that does not apply for SQL Data Warehouse, but I can double check that. Actually, that's a good question.
All right, perfect. I think that's about it. And no one else
Okay.
has any more questions?
Okay. Well, thank you.
Well,
Thanks,
thank you.
everybody. I hope this everybody enjoyed this. Thank you. Thanks,
Thank
Crystal.
you, Bob, and we appreciate it. And we apologize, guys, about the sound, but you know, it's technology. You can't always get it right. But like I said before, if you guys have any questions or comments, please feel free to reach out to Bob or myself. You guys will receive a link in your emails tomorrow, probably about noon, with the recording in there. The recording should be on the website by the end of today, but if you guys want to just get the link directly, it will be in your emails tomorrow. So if you guys have any questions, feel free to reach out to either one of us. And thank you so much for joining the webinar. We'll see you guys next week.
Thank you.
Thank you.